Welcome to this video about organizing our Blazor server application by using the vertical slice architecture. In the video description, I have two links to two great videos which explain it in great detail. The main goal is that we don't have layers. We have everything organized in a vertical slice, and this allows us to make changes way easier. So to show you one possible implementation of this architecture, I'm going to create a new class library, call it models. Here I'm going to create the only model for this application, which will be a product. The product class will have three properties. The first one of type int, which is the ID. Second one of type decimal, which is the price. And the last one of type string, which is the name. Now I am also going to create a second class library. This class library will be our data access layer. I just call it data access. Now in the introduction, I've told you that the vertical slice architecture is competing with the layered architecture. And you may ask yourself, why am I calling it? Okay, I've named it data access. Yeah, this class will emulate DB context, as we would know from Entity Framework Core. And the DB context, of course, is a DB set. In this case, the DB set will be emulated with this list of product. Now, I call it products, and it will be auto-implemented property. And I have to import a namespace. And in the static constructor, I'm just going to initialize the list. I've copied the code here. So here I'm just going to create 4 new products. Now, yeah, that's our data access, that's our models. In a real world application, of course, we would have Entity Framework or something else. These are the only two things that are very closely that you can compare to the layered architecture. And so you could also name it data access layer. But now we are getting into the real vertical slice architecture. Therefore, I'm going to install two NuGet packages. The first one is mediator, and the second one is mediator dependency injection something. Now, the mediator package is basically a library that allows us to implement the CQRS pattern, or CQRS standing for Command Query Responsibility Segregation, or also in a broader way, the mediator pattern. And the mediator is basically an object that encapsulates the logic how two objects or more should interact with each other. So to register mediator, I have just here to add it to the service collection, and then it wants the assembly. This is necessary because it works over reflection, and so it has to discover all the registered classes. Now, vertical architecture, vertical slice architecture is also called organized by feature. So it's not called organized by feature, but that's one of the setting points, so that you have to organize the code by feature. Therefore, I'm going to create a new folder and call it features. In this application, I'm only going to create one feature. So I'm going to create a new subfolder, and this is the add product feature. Now, what do we need to implement this feature? We need a radar component. I call it add product component. Now, in here, I will quickly have a little definition, so that you maybe can understand it a bit better. Alert, info, Oh no, of course not. In this component, I'm going to build the real functionality. I've misspelled. Here in the index component, I'm going to give a little theoretical introduction. It won't be as good as the links that I've provided, but I think it will. I hope it will help at least a bit. So now the title is that's a feature. As I've told you, the vertical slice architecture is feature-based, so a vertical slice has one goal, and that's to be a feature. And a feature, as the name suggests from English, it's just something that does something, like email sending, or in this case, adding a product. Now, that's the important stuff here. The mediator is basically handling the interaction of two objects. In this case, it's the request and the response object. So we will communicate over mediator a request. This request will be processed by a handler, and the result of this processing will be a response. This request response will be defined by a class, by a type. In this case, it's the add product request. In this case, the add product response. And what the handler is doing, it will also be implemented as a class. It transforms the add product request to an add product response. And here I have the link for this image will also be in the video description, an image of the vertical slice architecture. So I just quickly going to show it to you, because I think then it will be a bit clearer what I'm going to build now. So instead of having different layers like the business logic or data access layer, we will organize everything in a feature. I'm not an expert. I think that the whole data access layer with Entity Framework Core is pretty much the same as we would build it in the clean architecture, so speaking from ASP.NET Core. But what is different is that we don't have a repository and that kind of stuff. We have everything organized in this features folder. And the features folder, of course, has subfolders, which will only define one feature. And in this subfolder, we have at least 3 types. We have a type that represents the request, the handler, and the response. And these 3 things, request, handler, response, are basically one slice here. So I hope it became a bit clearer, but it could very well be that it didn't. And then, as I've told you, the videos are a great source. Now I'm going to create first the add product command. The question is now, what kind of information do we need in here? We need 2 properties. First one is the price of the product, and the second one is the name, because the ID we can generate it. Now this has to implement iRequest of t. Why iRequest of t? Because everything that follows here as the generic type argument will be. So this is basically for the event, for the handler afterwards. If we send an add product command, then we expect an add product response. Now here we have created the add product response. This type will have two properties as well. First one indicates if the whole operation was a success, and the second one just gives back the count of all products in the database. Now, the most important thing is the add product handler. Now, this will implement iRequest handler. Here we will pass in the response, add the response, the request add product command, and the response add product request, and add product response. I'm sorry for the misspelling here. And as you can see here, we have a generic constraint. So this type here has to implement the interface iRequest of this type here, but we have done that. We just need to implement it. Now, because we want to run it asynchronously, I mark it as async. And here in this method, we see we are getting past add product command, and we have to produce an add product response. Now, how are we going to produce it? First, I have to, over constructor injection, get the product context. Now I need to add a reference as well to data access. Import the namespace. So now here I'm going to create a new product. Why is this not okay? So name will be request.name, price request.price, ID will be the product context, here the context dot. I've just realized I don't even need the injection, the construction injection, because everything is static. Products count +1. So actually we can just delete this here. Yeah, I'm very sorry. I've defined the list of product as static, so we don't need the injection. And then product context, products, add product. And now we are actually returning our response, success, true, and total products, or now, how did I call it, count, equals product context, products count again. Now I've told a lot about a request and the response. Here response is in the name. Now here add product command. Why didn't I call it add product request? Because a request can either be a command or a query. A command is basically updating the database, and a query is just getting information out of the database. So, and now of course I have to, here in the add product component, actually build it. Here I have to inject mediator so that we can actually invoke the whole thing. Add product component, and then add product command, call it command, and add product response. Now here I'm just initializing the command. And then here I'm going to bind. So class form control type text. So this will be for the name property command name. And then I will create a second input field, which will be for the price. So here number and command price. Then I'm going to create a button. And when we click this button, we will run an asynchronous method. And this asynchronous method will send the add product command. So response equals await mediator send, and here we have the command. So everything is asynchronous, and then we just say the command. So we will be resetting the command so that the values are getting reset. Not that important for this simple example, and then we call status change because we are in an asynchronous method, and then the diffing algorithm or then Blazor doesn't re-render by itself, so we have to call it manually. So the important thing is, if we send the add product command, mediator knows what will be the result. That's the add product response. Okay, now I see. Yeah. So the add product response will be the return type of the method, and then we just display it. You have to call async, otherwise it won't work. And then here, of course, I have to call the method. So now I think it should work. Let's have a look. Okay, of course I have to in index add the component. So I can just type something and then add the price, click here. Okay, we don't. Yeah, here I also forgot to display the response. So if the response is not equal null and the response has succeeded, then we are just displaying success and the count of all products. And here I'm just giving you the name add product. So let's just run the application, and then afterwards I will have a quick recap over the folder structure. So yeah, type something, and then you give it a name, and you give it a price. Okay, success. Now we have 5 because we started with 4. But of course, that's not the real thing. The real thing is how are we getting to this point? How have we architectured? How have we planned the application? So everything is organized by a feature. We have mainly 3 types: the request, handler, response. The handler acts as a transformer between these two things. Here, this vertical slice is organized in the add product, which is the name of the feature, in the features folder. What is also very important is that a request can either be implemented by a command or a query. The command is changing the underlying database, which we are doing here. We are adding a product. A query would just be to retrieve all values. And now maybe at the end, why are we doing this? Because if we build a classic layered architecture, I think it works very well if you know that you are not going to change the entities. But if you're going to change the application afterwards, you are going to change the database scheme whatsoever, it's way easier if you have built it here as features. Because in here, you don't have overly lot code that depends on this, so you can quickly add something without having the fear of breaking another thing. And I think that's the main strength of the vertical slice architecture. So I hope that I've showed you in this longer video how we can, on a conceptual level, implement it also in Blazor, and how we should, if we do it, should store everything that has to do with one feature in one folder. So thank you very much for your attention.